Good morning, everyone. So we have three speakers on stage, and myself, Punith. So I'll be starting the presentation, and then I will hand over to Peter. He's also co-lead for fluids and materials. We both work together. And then finally, Rolf will cover on the immersion requirements. So just to give a background, so last year we did a couple of white paper publications. One was on material compatibility for immersion, plus we also did the fluids specification guidance that actually Intel started, and we published this last year. So I think that was probably the key deliveries from our work stream standpoint. There are many aspects we covered, various fluids that prevailing in the market with respect to single and two-phase, how they interact with the components, and what are the parameters we need to measure to understand the interactions with the components with the different fluid chemistries. And then what are the key parameters we need to evolve, measure, as well as the criteria that was set for these testing. And then in the second work stream activity that we was on the fluid specifications. So Intel started the work mainly covering the performance-based specifications because in the first publication on the fluids, we talked mainly on the basic properties of the fluids. What are the properties that we need to measure with respect to electrical properties, fluid, physical, thermal properties, and so on and so. I think the performance-based specification was very enlightening for all of us because this actually gives an indication that what are the parameters that we need to measure in order to basically tell the fluid manufacturers whether the fluids are actually qualifying that will end up performing with respect to cooling performance. So one of the key parameters they developed was something called as figure of merits. And this is actually, this composes of many parameters of fluids, and then they have defined some of the specification criteria that what are the figure of merits involving whether it is natural-based convection mechanism or with the forced convection. So I will run through those numbers in the end, but these are the three areas that we did last year. This year, I think we spent most of the time, first 3-4 months, is to try and understand what are the main topics we want to cover. What are the key gaps that is presently available in the market? How do we address that? So these initiatives that we did was basically coming from the community itself. It's, yes, we both did a lot of brainstorming about what are the, the topics that we want to run on. But I think these are the above listed ones which are mainly that we mainly focus this year. So there were 7 subgroups we created. Under fluids and materials, there are many subgroups that were created, and we actually made it into smaller groups led by individual leads for these dedicated smaller work streams. And I think I would say more than 50% of these subgroups activities is already kicked off. I think we would like to cover the 2 subgroups which are actually made significant, or 3, which has made significant progress this year. And hopefully we will see at least maybe 1 white paper will be published. We are hoping that's the case. So the main top 7 topics that I'm thinking about is, the main one is failure mechanism analysis, FMEA. This is very important topic because I will cover in the next slide. That's one. And then the fluid oxidation stability with respect to how the fluid performs with respect to when it is exposed to longer term in service. And then component level testing. That is actually an ongoing project that everybody wants to know more and more because we actually deal with a lot of newer materials as we speak. I think last year we were mainly focusing on the component levels. Then we actually moved into the server levels plus the tank levels. So these got into different subgroups. And finally, I think in this year's regional summit, there was some questions about how do we handle fluids. So that one of the primary reasons we actually dedicated a workstream effort on that. And if there is any specific questions you would like to contribute in these, then I would suggest is reach out to these leads or reach out to us. We will connect you because we need active participation here so that adds value for these workstream efforts. And this slide, as I said, the failure mechanism, because the systems that is actually being built on, so most of the manufacturers are actually looking for IEC test method, IEC 63, 62, 368. So this standard, which actually gives you an indication how this solution is actually behaving with respect to fire safety aspect. So last year we had a specification for fluids for auto ignition temperature, which is basically is part of the fire safety aspect for the fluid. So that was actually published for 250C. But now, because IEC is already inbuilt for all the dielectric fluids that come into play for certification, that was actually published as 300 minimum AIT values. So due to which, to harmonize this, we actually raised the AIT values to 300. But now what we are doing is trying to understand whether we just directly adopt these minimum criteria. If not, specific to immersion applications, what are the key heating sources that we have when you are actually in immersed condition, considering all the failure mechanisms. So AMI is doing an excellent job. This whole team here on the right has been listed here. So we are all chiming in based on the experiences we gather with respect to fluids, as well as the components, how they behave in the actual application. We're going to map this and then provide a guidance next with the publication, with the recommendation for single-phase fluids. And then finally, this will be taken by the immersion requirements leads. They're going to actually present this to IEC for making recommendations for changes. With this, I will hand over this to Peter.
Yeah, thanks, Punith, and hi, everyone. So the next group we want to kind of dive into a bit more is about oxidation stability test procedure. And this is a group that's led by Ken Hope from Chevron. And the basic idea here is that, so up until now, everyone's kind of been formulating their fluids, right? We've come up with some minimum requirements in the past with OCP and a base specification by Intel. But in terms of oxidation, which is kind of a #1 concern, right? Everyone wants to know how long is a fluid going to last. In terms of oxidation test procedures, there isn't really an agreed upon standard for immersion, right? And that means that you could go to the supermarket and buy olive oil from the shelf, right, and stick it in the tank, and you're probably going to meet most of those minimum requirements. But obviously, as we know, that's not a good solution, right? So this is about kind of finding a common test procedure, right? And the strategy that we're taking here, we've kind of broken that down into different, 4 different objectives, right? So the first is basically to do a review of the existing standards that are out there. We don't want to reinvent the wheel. If there's a standard which already applies fairly well coming from the industry, that's obviously the preferred option. After that, we're going to look at taking those standards or some of those standards. Are there ways we could improve those to be more relevant for immersion, right? The immersion context. The second thing is about, in terms of coming up with those recommendations, we need to balance. In the end, what we're trying to do here is predict behavior that's going to happen over years in a space of days or weeks, right? So we have to try and balance, accelerating the aging, but at the same time, not going too far and the test not being too long. The third thing, which is, I think, really key, and this applies to a lot of the work going on in the immersion community right now, is collecting some actual data from in-service fluids and comparing that data with some of the test results we're getting from the test methods, right? And so we've, as part of Submer, we've contributed some of our data already, and that's something we really encourage others to do as well. The last thing is, in terms of coming up with these new test procedures, I think everyone's kind of has it in their mind that we'll probably have to include something else, some other kind of, in the traditional methods, for example, you might inject oxygen into the sample to try and accelerate oxidation. We know in immersion, you can potentially have lots of different materials that are exposed to the fluid, or the fluid is exposed to those materials. And so we foresee that we might have to look at which materials might we dope into those fluids to simulate the immersion environment. So just a really quick kind of summary of where we're at right now. Here on the left, you can see a table of two of the most relevant standards that we've identified. One of them is from IEC, and the other's from ASTM. So far, I think that we see them as being quite relevant. There are two different approaches. One of them is heating up the fluid to 120 C for a fixed amount of time. The other one is at 140 C, and it basically, you end the test when you reach a failure point. And what we have seen, though, is that those tests could definitely be improved, especially on the side of which properties can be measured, and like I just mentioned also, should we be adding in some kind of additional contaminant to speed things up. So yeah, I'd encourage anyone who has data that they could contribute to this at this point in time, that would be really helpful. Then the second one I wanted to talk about was so safe handling of fluids focus group, and this is work that's being led by Spencer Kearns from Chevron. And the basic idea behind this one is bridging the gap between the chemical side, so the chemists who are familiar working with safety data sheets, they understand the terminology of GHS, that hazard statements, and bringing that into the data center space, into day-to-day operations, right? How do we interpret all of that information and put it in the context of immersion, right? So 4 basic goals here at the moment. Fluid handling guidance is obviously really important. PPE, things like that. Regulatory is also going to be really important, right? In terms of controls or building codes, etc. Industrial hygiene monitoring. How can we make sure that things are going smoothly, exposure, etc. is under control. And also a bit of product stewardship, right? So yeah, on the fluid formulation side of things and documentation, what are the kind of best practices and guidances there? So we last week presented the first draft of this document to the community, and we're going to open that up to open comment. I'd encourage anyone who has experience running immersion systems to jump on there and give all the feedback you want. Also, anyone who has a background in OH&S guidance and regulatory especially, that would be helpful. At the moment, as a kind of quick summary of where we're at, we've got a whole wealth of information right now on all the different fluids that are being used in immersion, from synthetic hydrocarbons to esters to fluorinated fluids, right? This is not just single phase, it's also 2-phase. We've got spill and cleaning procedures, product storage, and handling recommendations. We've parked a bit of the regulatory stuff because it is a complex area. That's why we do invite people to come forward in the future and provide a bit of guidance there. And yeah, there are lots of other things. I really recommend you to check the document out when we release it to the public. Thanks. I'm going to hand back over to Punith.
Yeah. Thanks, Peter. So this one, I would say I think there will be a very detailed conversation will happen in the afternoon. Jessica will go deep dive into the specification, how they developed. But I just wanted to show you just a snapshot. several properties, actually is being listed. There are some specs for both single and two-phase. We are not categorizing this as different chemistries based on single phase, but in general, just put in one basket the specification limitations for single as well as for two-phase. So I think the main takeaway here is something new, and also it is performance-driven, figure of merits. So I would really suggest everyone to use this link. More information is actually already been captured in the white paper, and you will know what are the properties that fluids should have to get these increased FOM values so that it actually performs and provides a good cooling behavior. With this, I will request Rolf to run on the immersion requirements.
Well, thank you, Punith. And great stuff. This is some really exciting work that's happening in the fluids and materials group. So a year ago, when the previous document was published, the amount of variation that we have now in the fluids and materials group is really exciting. And a lot of the work is being harmonized with immersion requirements as well. And just want to get a little bit into this. We've just released the immersion requirements revision 2.1. And the purpose of immersion requirements is something that I would like to give you a little bit more insight into. Because we have these requirements to provide a common terminology, to establish a similar baseline across all these technologies that relate to immersion cooling. And we want to be able to specify some minimum engineering level across the industry. We want to make sure that everything can achieve a certain level of quality. And for that, we also need to make sure that we can compare technologies as well. So we want to get beyond the normal marketing information that you would get from different vendors, and we want to be able to ensure that we have a really good view of what these immersion technologies can actually do. And that is necessary also to help advance the industry and also to help provide input for the global regulatory aspects around immersion. We have to make sure that immersion cooling is a term that exists in legislation or in standards. If there's if the term immersion cooling doesn't exist, there's no certification you can ever achieve, no standards that you can implement, right? And that is really critical. All right, that's odd. Anyway, so with these immersion requirements within OpenCompute, we require any technology that relates to immersion, whether it's a fluid or whether it's an immersion tank or some other solution that has aspects that we've covered in the immersion requirements document. We require those technologies to qualify against that document before gaining access to anything within OCP, like recognition for a spec or a white paper or a product positioning on the marketplace. Right? There's a few products on the marketplace, but they can only get onto the marketplace if we've assessed that they comply with the immersion requirements. That also means that we can have that minimum level of safety for operating these technologies. We also require disclosures. Immersion fluids, before they can get access to anything through immersion or can be carrying any kind of logo or can claim that they comply with an OCP spec, they have to comply with the requirements. It means that they must show that they're disclosing fluid properties, information, the technical information about the fluids, performance information, or whatever we have defined within these fluid requirements. An example of this, and these are empty sheets, and I'm gonna get into the fact that they're actually empty, but this is the newly released overview. This is an example of one of these spec sheets that is being generated out of the immersion requirements documents. Now, here's the funny thing. We established these requirements together with all the industry stakeholders, all the participants in the community, all the fluid manufacturers, all the immersion vendors, and we all said, okay, yes, we want everybody to disclose this. And it comes out. And there's not a single fluid that has actually come out and shown this list filled out. And this is something that we need to start seeing. We must start seeing the properties of these different fluids so that people can start assessing these fluids and preparing for the use of these fluids. Everything that was just presented and discussed in these focus groups, how do you handle fluids? That's only possible to assess as an end user if all this information is also filled out. How is your server going to perform? You can only assess that if this information is filled out. What does the figure of merit look like? How can we anticipate a certain chip or CPU to perform in a specific type of fluid? Now here's just a few sample charts of what that figure of merit might look like for a given fluid, but we haven't had any fluid being submitted yet to actually go through this motion. It's not a big deal. All these fluids know what their properties are. Very often they also know what their competition is doing. These are not really secrets, but they're still dealt with as company secrets. And that is one of the inhibiting factors of the progression of immersion cooling. So we really need all the fluid manufacturers to come up and start showing the data, start sharing the data, because only then can we move forward. In the latest Immersion Requirements, revision 2.1, there's a couple of points that I'm just very quickly going to touch upon, because really we've gone into depth of all these figures over the past summits. There's a whole document that explains it. It's called the Immersion Requirements revision 2.1. A couple of highlights that have changed since revision 2.0 is that auto ignition point has been increased from 250 to 300 degrees C. Why is that? Is that because we feel that 250 degrees C is dangerous? Actually, no. It's because IEC requires that. So if you want to have any kind of certification, UL certification, CE certification, you must be 300 degrees Celsius anyway. We're not in a position to state otherwise, to recommend anything lower, because it will prevent any kind of recognition. Therefore, we have a liaison role with IEC. And we're going to be providing a case study or evidence to support a certain temperature that might be appropriate for not only auto ignition point, but also flash point. That's where the FMEA study comes in, which has already been explained. And that's something that we take very seriously. And it doesn't matter, we do not know yet whether that's going to be a lower value or potentially even a higher value. We don't know. It depends on what comes out of the FMEA study. There is a new topic, which is the thermal loss to environment. Look, an immersion tank, fantastic. Liquid cooling technology, absolutely marvelous, super efficient. And the liquid cooling is superior. We all know the stories. But the reality is, if an immersion tank, when it's in operation, it contains warm fluid. It contains equipment that is generating heat. That heat is being lost also to the environment. Right? It radiates, it loses, there's maybe some air ventilation over the fluid. So it is important for facilities to understand how much of that heat will end up in the facility, because that is going to be part of the load of the air cooling in the same environment. We still need to cool the air around liquid cooling equipment. So even though liquid cooling is fantastic and you work with elevated temperature, super efficiency, and yes, you get rid of air cooling, well, not entirely, because you still need air cooling for the people and the operators to walk around the facility. And therefore we need to quantify the type of how much thermal loss there is. There is a new definition for it. It's expressed in kilowatts. We've outlined a process and a procedure in which you can establish these figures. And now we require that figure in kilowatts as well as part of the new revision. We're going to see how this goes, how this works. We haven't done this, it's still too fresh. We haven't seen any figures come in from that yet, so we're hoping to get some of those figures in soon. But this is the test outline that is now revised. And I'm going to skip out on the process. A good thing to note is that the process should be identical for both single-phase and two-phase technologies, but it does only apply to open bath technologies. So that's a thing, that's something to keep in mind. With that, just if you would like to get access to the Immersion Requirements revision 2.1, here's the QR code. And of course, you can find it on the contributions database on the OCP website. Right, for now, I just want to say, hey, get involved and join these sessions. We need your insights, we need your help. Share your information. If you have a product and you feel that, hey, I want to have this, I want this product to be seen, and you know that it will, or it may or may not qualify against the requirements. It doesn't matter. Just go through the motion. Help us and help us also gain insight. If you have trouble achieving these requirements, which are designed to be easy to achieve. If it's not achievable for whatever reason, let us know and see if we should change some of these requirements. Share the outcome of these spec sheets in the community. Use these spec sheets in your own documentation. If you're a fluid manufacturer, these spec sheets, the styling and the type of information that's in there, please include it on your technical data sheets. Use the same format, try and progress this work that we've done here with the larger community. So with that, I wish you a lot of fun with the next couple of sessions. There is 1 minute left for a potential question to the leadership here or myself. Anyone? It seems that we're so good in explaining everything, right? John Summers.
Hi, Rolf. Yeah. So I do have some data about the thermal losses because we've run an immersion system in a containerized environment in a very harsh climate, and we lost 55% of the heat generated by the IT. Question is why do we use black all the time? We should be using much lighter colors.
Black and whiter colors. All right, that's a great statement. And it's also interesting to hear that some of these technologies, they can actually lose a lot of energy, which is why we need to have visibility on this, right? And it's not strange to lose some energy to the air environment. That's why we need to quantify it and focus on insulation and making sure that these tanks, these solutions will be well insulated. I think we're out of time. So thank you very much for your attention, and thanks to the Materials and Fluids community for all the work that they've done.
Thank you all.